Alright, so here we are continuing our Unity Game Essentials project. What I'm going to do is start off by creating the scene folder for our scene system. Okay, and we're going to have three scripts that we're going to be working on in this tutorial. The first one is going to be our test scene script. And the test scene script is, of course, the script that we're going to use to test our scene controller system. I can go ahead and drag that onto our test object just because I know that's going to be there. And then I'll turn off the test audio object here. We might actually end up moving some of this stuff around as we will have to create a scene to start from, but we might also just end up starting from this menu scene. We'll see how it goes. The second script that we're going to create is going to be the scene type script. And that's just going to contain our enumeration for different types of scenes. Finally, the third script that we're going to create is the scene controller. So we'll call that scene controller. So as usual, let's go ahead and start off in our test script so we can define the rules for our scene controller. The first thing that I'm going to do is clean up the script a little bit for our test scene, and then I'm going to create the namespaces. Once that's done, we're going to need a reference to our scene controller itself. And then I'm going to set up our testing regions. Okay, so let's just talk about this code that was just added. We are going to be checking for input in the update function, which is of course a Unity event function. That's pretty standard. What we're doing first is we're checking to see if we press M, and if we press M, then we're going to conduct our first test. So one of the things that we want to do is be able to load a new scene. So the first parameter is the scene type. And then we want to be able to check to make sure that that scene was actually loaded. So we pass a callback function here, which is this highlighted region. The callback function only gets called after the scene is loaded. And then whenever that happens, we simply log that to the console. The third parameter here is a Boolean to determine if we should reload this scene type if it's already loaded. And here I've selected to set that to false. And you would do this if you didn't want the scene to be reloaded. So if I set this to true, then if I was on the menu scene and I chose to load the menu again, it would actually reload that scene. So sometimes that behavior is desirable if you're resetting the game, for instance, or if you set that to true, if you set this variable to true. If you set it to false, then maybe you don't want to accidentally reload the scene if you're currently on it. Okay, and then the third parameter would be the page that you would want to load or turn on as you're transitioning through these scenes. Okay, the second field here, the second input that we're checking for is G, and if we choose G, then we simply load the game scene. Okay, so we're going to be going back and forth between the menu scene and the game scene. So let's go to the next easiest script here, and that's going to be the scene type. We've already sort of used some of these enumerations. Let's create the namespace. So we're going to be in Unity Core and scene. And this is going to be a simple enumeration called scene type. And for the purpose of this tutorial, we're going to have none, menu, and game scene type. Now let's head over to the main system script, the scene controller, and start filling out some of the details here. I'm going to start off by cleaning up the script a little bit, and then we'll add new namespaces as we need to. I'm going to define, of course, just as always, the Unity Core .scene namespace. And then I'm going to place the contents of the script into that namespace. Okay, so let's just start off by defining some of the member variables that will be needed for this system. So first of all, let's just go from the top to the bottom here. We have a SceneLoadDelegate. This is going to define the callback parameters, or the callback signature for the function that will get called back whenever the scene is actually loaded. If you remember from our test scene script, we have the callback that's getting passed as a parameter here. That is the SceneLoad delegate that we've defined here. Okay, second, we're going to have a public static instance or reference called instance to the scene controller. Of course, we're going to have our Boolean for debugging to determine if we want to debug the script. And then working our way down here, we have some private member variables. We're going to have a reference to the menu or the menu system. So we're going to go ahead and go up here to our namespace region and add a new using statement using Unity core.menu. And again, if you're confused about where this is coming from, we did a tutorial on this where we created a menu system. I'll go ahead and leave a link to that in the description so you can watch that and understand how we're going to be integrating that in this tutorial. Okay, we have the target scene type that we're going to want to hold a reference to. We have the loading page that we'll hold a reference to as we're switching scenes and loading pages. We have a reference to the current load delegate, so we can call that after the scene is actually loaded in the Unity defined event callback. More on that a little bit later. And then we have a bool to determine if the scene is actually loading. Now that we've sort of talked about some of these member variables, let's create some properties that we're also going to want in this system. Okay, so two properties to create here. We have an integrity check on the page controller or the menu system reference. So what we're doing here is we're saying, you know, if the menu doesn't exist, if our value for our page controller doesn't exist, let's go ahead and initialize that here. And then after we initialize it, we'll do another check to see if that still exists. If it doesn't, we'll go ahead and log a warning to the developer and finally return that value. Whether this is null or not doesn't matter, because as we use it throughout the script, we'll be checking for that. So our second property here is get the current scene name. So that's going to be utilizing the Scene Manager API, which we're going to have to add a reference to up in the namespace section. So let's go ahead and make sure that we have the proper tooling for the Scene Manager. So we'll come up here and we'll add a using statement for, or I'll keep all of the Unity Engine ones collected here. So we'll say using Unity Engine dot scene management, just like that. Okay, so we're getting to the point where we're going to want to start defining some functions. As you can see here, we're already using a log warning function, which hasn't been defined yet. We're going to go ahead and skeleton out the functions that this class is going to need. So we're going to start off by just defining some regions here. We have a region for Unity functions. That's going to contain functions that derive from auto behavior, things like awake, start, on enable, on disable, whatever you need to use from mono behavior, we'll go ahead and throw inside of this region. We'll have a public function region, which is going to basically outlay the API requirements for the system. So anything publicly accessible through our instance. And then the private functions, which will be basically our helper functions for this class, inaccessible to anything outside of it. And I should mention that these regions are completely optional. I use them for code organization. You don't need to use them yourself, but again, I use them purely as a personal preference. So up to you guys on that one. So let's go ahead and fill in some of these regions with some actual functions. Okay, so the only two Unity functions we're going to need are awake and on disable. Inside of awake, we're going to be initializing our singleton pattern, which is going to initialize the instance. It'll destroy the game object if it's not the instance, and it will make sure to call don't destroy on load if this is the actual instance that we want to use. And we'll also be doing any sort of system initialization inside this awake function as well. In the on disable function, we're going to be doing any sort of disassembly that we need to do. There will be a coroutine in this system, so this would be an area where we would be making sure that we stop that coroutine here. Okay, the only function that we're going to have as part of the system's API is a function called load. It's going to take one mandatory parameter and then 3 optional parameters. If you'll remember from our test scene script, one call that we do here uses all 4 of the parameters, including the 3 optional ones. And then our second call only uses the first mandatory parameter, which is of course the scene type. So what the load function is actually going to do is first check to see if we have a loading page. It's going to check to see if the scene can actually be loaded. based on several parameters, including this reload parameter that comes in, but we'll also be checking for other cases as well. And then we'll just be starting off the coroutine to actually utilize the loading page if we need to, and then load the actual scene. Okay, so obviously our private functions region is going to take up the majority of the script. As you know, we try to abstract as much of this functionality as possible, so it's not accessible to classes outside of this system. So of course we have the configure that's going to be called in awake whenever we're initializing the instance. Dispose is going to be called in on disable, the Unity function that we have up here. Of course, dispose is just going to be getting rid of any resources that we need to get rid of. On scene loaded is going to be something that we subscribe to for whenever the Unity engine scene management. Actually, this is simply put, this is a callback for Unity engine.scene management. So this is what you can actually subscribe to the actual Unity engine callback. And the parameters for that callback are the scene object and this load scene mode object. So that's going to be something we sort of piggyback off of when it comes to the Unity engine. So then we're going to have the load scene coroutine, which is going to handle any sort of waiting that we need to do. In some cases, of course, we're going to have to wait for the menu management system to actually pull up the loading page. So that's why we have that as a coroutine. And actually, while we're talking about it, since we're using coroutines, we're going to have to come up here and add another using statement for our system.collections. Okay, so just working down the list here, we're going to have two helper functions that are going to help us convert scene names into scene types and vice versa. We'll see where those are actually used here. And then the logging functions, of course, are down here for log and log warning. We'll probably implement those first since those are definitely the easiest. So let's go ahead and start there. So pretty straightforward stuff here. In each one of these functions, we're checking to see, do we want to debug? If we don't, then we're just going to do a simple return, so we don't do anything else. Then we're going to utilize the Unity engine debug object to actually log the message that we want to log. And of course, we're adding a prefix of the system name to that log, so it makes it easier for the developer to understand what's going on and what's actually throwing this result. The log warning function is an exact copy of the log function minus the actual name of the function that we're calling with the debug object. So instead of debug.log, we're calling debug.logWarning. Okay. Before I go any further and get into the implementation details of this system, I want to make sure that so far, since we've written quite a bit of code already, I want to make sure that so far everything, we're not going to have any errors. So we do have some return types in some of these functions. Let's go ahead and just return some dummy values. So we'll return string there, and we'll return a scene type here. We have a bool return here, so we'll return false. Coroutine, we're going to want to yield for this coroutine. But nothing else returns anything. Let's go back to Unity and make sure we don't have any errors before we start implementing some of these details. Okay, so we do have a couple errors. Let's go ahead and resolve those. Invalid token bool, and then an invalid semicolon. Let's see what's going on with that. So completely dyslexic here. We want to say this is a public bool called debug. And that should get rid of, oh, we have a couple of more errors popping up here. Page type does not exist in the current context. So inside of our test script, we want to make sure that we're getting the correct reference for that page type. So here we're also going to use Unity core.menu. Okay, back in our scene controller, the name message does not exist. That's actually string, not message. So this is why we do this, because since we've already written quite a bit of code, it's just natural to make some mistakes along the way. Okay, so we've cleared up all of those errors. Now we can finally get into the actual implementation of the system, the fun part that I'm sure most of you guys are here for. So let's go back to the scene controller and start filling in some of these functions. Now it's also worth mentioning that we're going to be making some changes to the management system, the menu management system itself. So if you haven't done that tutorial, you're really going to want to go through that so you understand why we're making the changes that we are. But without further ado, let's go ahead and start implementing this. Let's start with our awake function. Okay, so what we're doing here in awake is we're checking to see if the instance exists. If it hasn't been initialized yet, because remember this is a static member, there can only be one of these. If it hasn't been initialized yet, we're going to configure the system, and then we're going to use this Unity function, don't destroy on load. You don't have to create this one, Unity creates this for you. And then we're going to pass this game object in. So if you think about it, this is kind of necessary because this scene controller is obviously going to be needed from scene to scene. This don't destroy on load call tells Unity not to destroy this object whenever we jump to another scene. So this object, this instance of scene controller, is going to persist through all parts of the game. So if the instance does exist, let's say the scene controller was on a scene that we're going to, in that instance you would have two scene controller objects, but the second object would recognize that the instance already exists. So it's going to drop down to this else statement and it's going to destroy itself. So that's what's happening here, and that's going to ensure that there's only one copy of the scene controller out there. The onDisable function is very simple for now anyway. All we're going to do is call dispose, which is a private function we defined below. Let's move down to the load function. We'll just work our way down linearly throughout the script. So we're going to work on this public load function, which is essentially the controller for the main requirement for this system. Okay, so we're starting off here from line 64 and going down to 76. So the first thing we do is we say if the loading page is not equal to none. So in other words, if the user of this system specified a loading page and the menu is not initialized, then we want to return, because if the user is trying to use a loading page and the menu is not available to use that loading page, we're just going to return. Obviously, the behavior that you choose here is up to you. You could simply set the loading page back to none and then continue loading the scene. For now, what I'm choosing to do is just return, making that a set of parameters that is invalid and thus not loading the scene. The second thing that we check for is whether the scene can be loaded or not. And this is a private function that we define below that we're going to implement a little bit later. But essentially what this is going to be doing for us is making sure that everything is okay and ready for us to load the scene before we do anything else, like starting this coroutine. So moving down from line 72 to line 75, we're just initializing some of our private class members that we're going to want to be able to reference between our function scope. So these are variables that that don't need to be withheld or contained by the local scope of this method. We're going to be referencing these variables throughout the entire system. So that's why we initialize these here. All we're doing is saying that the scene is loading. We're initializing the target scene in the loading page, and then we're initializing the delegate in case the user specified a callback. After the scene is actually loaded, we're going to use this callback if it's not equal to null. And then finally, we're going to kick off the coroutine to actually load the scene. Okay, so that's all we have for public functions. Now we're going to work our way down and start implementing some of these private functions. Some of them we've already used up above, and then some of them we have yet to use, but we'll just go top down here and start implementing some of these. And of course, I'll continue explaining exactly what it is that each one of these are doing. Okay, so in our configure function, if you remember, configure gets called whenever the static instance is initialized for the first time. We initialize the instance by saying instance is equal to this, and then we use the scene manager, which is a Unity engine object. So we use the scene manager. Again, we don't have to define that because Unity does for us. And then we subscribe to the scene loaded event. The way we do that is by saying plus equals and then passing the function signature or appending the function signature to that event. So that onSceneLoaded is this function right here. So the Unity Engine Scene Manager is going to essentially call this function for us whenever the scene is loaded. So let's talk about dispose. Dispose is really easy. All we're going to be doing is unsubscribing from this event. So anytime you subscribe to an event, you want to make sure that you also unsubscribe somewhere within that same class. So let's talk about onSceneLoaded and what we want to do here. So the first thing that we do in this onSceneLoaded callback, or I keep calling it a callback, but it's not really a callback, it's a subscription to an event. But the first thing that we do in this is we check to see if the target scene is equal to SceneType.none. If it is, that pretty much means that the scene was loaded by a system other than this one. And so in that case, we don't really want to respond to that. The second thing we do is we get the scene type from the scene name, and that's why we have this string to scene type function. This is a function we're going to implement soon, but this is a private function to this script. And so what we do is we say if the incoming scene type is not equal to our target scene, and then we also return. And so this is a case where maybe we just aren't really sure why. We aren't really sure why the target scene would be different from the scene type that was loaded. If the scene type is not equal to none. Again, this is a situation, this is a place where your behavior might be different. In this case, I'm going to return because it doesn't sound like it makes sense. So I don't want to take any further action. But again, your behavior here is completely optional. It is something that's worth checking regardless, though. The next thing we do is check to see if our load delegate is null or not. Remember that the SceneLoadDelegate is the callback function that the user of the system uses to notify them whenever the scene is actually loaded. So if you remember, if we come up here to our public load function, the user of this is going to optionally provide a load delegate. This delegate is what gets called here if it's not equal to null. Okay. To further explain this, back in our test script, we're passing the second parameter as a callback function. So this callback function is the SceneLoadDelegate that we're working with here. Okay, so what we do is we check to see if that's not equal to null. So if it exists, then what we do is we try to call that. The reason we try to call that is because it's possible that when this test object calls load, the object gets deleted before the, of course, depending on certain circumstances, it's possible that this object gets deleted before the scene gets loaded. And so what would happen is this would essentially become null. Okay, so we'd be calling this, and this function here wouldn't actually exist. So Unity would throw an exception. Okay, so we need to go ahead and just try that, and then we can catch. What we do is log a warning. Your verbiage can be whatever you want it to be. Here I'm saying that we're unable to respond with SceneLoadDelegate after the scene loaded. So it's possible also that we can get rid of this condition here and just use this TryCatch. For some reason, this feels a little bit more robust to me, so I'm just going to leave it like that. Okay, so the next thing that we do whenever the scene is actually loaded is check to see if we have a loading page. Okay, and if we have a loading page, then we want to just wait for about a second and then turn that page off. So this is the whole reason why why this is an async function and we're using system.threading.tasks, because we want to just wait. The reason that I do this is primarily for testing, because technically you don't want to keep the player waiting longer than they have to. Because we're loading empty scenes, the load is pretty much instantaneous. And since we're testing whether this menu system is integrated properly, then we want to make sure that we can actually visibly see the loading page come in and go out. So that's why we have this 1 second wait. So whenever you're actually loading real scenes that take a couple seconds already, you can feel free to get rid of this requirement. Okay, and then finally the last thing that we do is say the scene is no longer loading. So we say scene is loading is equal to false. Okay, so now we can jump into our coroutine for loading the scene and see what that's actually going to look like. Remember, load scene gets called up here at the bottom of our load function. So that's the last thing that gets called. So let's see what is actually involved with that. So the first thing that we do is check to see if we have a loading page. And actually the loading page is the only reason right now that we even use a coroutine, because if we do have a loading page, we want to go ahead and turn the page on using this menu object. Again, the menu that we're integrating into this was discussed in another tutorial, and the link to that tutorial is in the description. Obviously the use or the integration of the menu system is optional, but here we're explaining how to do that. So we turn the menu page on, and then we wait until the page is actually on. In the event that we're actually animating this object or this page, if we're animating the page, we want to wait until it's fully animated in and yield while it is animating in. Okay, and then after we exit this condition, we know that the page is loaded if it's going to be loaded, and from there we can go ahead and call the scene manager load scene function. So the first thing we do is we pass in the target scene to our private function here, scene type to string. So we get the actual string of the scene type that we're trying to load, and then we use that string to pass into the load scene function for the scene manager. Again, just to reiterate, the scene manager is a Unity object. That's what's actually going to be loading the scene for us. And so that's all there is to it with this function. So the next thing we want to do is implement this scene can be loaded function. Remember, scene can be loaded is called up here in our load function, our public load function. We call that here to make sure that the scene can be loaded before we actually start the coroutine and set all of these private member variables. So let's go ahead and implement the scene can be loaded function. Okay, so this function is essentially checking for a set of conditions and checking to see whether we should evaluate this function to return false or true. So if you can think of any other conditions besides the one I have listed here, this is where you would add them. Basically, these are your controls to determine whether or not the scene can be loaded. So the first one that I use is whether the current scene name is equal to the target scene name. So if the current scene is equal to the target and we don't want to reload, then we don't want to do anything because we're already on the current scene that we want to be on. So if reload was true and we are on the same scene that we're trying to load, then we would continue on and go ahead and reload the scene. So then we say else if, so here's another condition, if the target scene name is equal to string empty, so basically if the scene name that we're getting isn't a valid or recognized scene, then we go ahead and return as well. Finally, we check to see if the system is already loading another scene, and if it is loading another scene, then we of course want to discontinue this process. Okay, so if all of these conditions pass and none of them evaluate to true, then we return true for the function. Okay, and so the only variable here that might be in question is this current scene name. You might be wondering where we get that. And a little bit earlier, we defined a property called current scene name up here at the top of the script. And all that's doing is returning the active scene name property from the scene manager object. Okay, so that's all we're doing in our scene can be loaded function. Now we just have two more helper scripts or helper functions to define here, scene type to string and string to scene type. We've already used both of those. Let's go ahead and figure out what's going to be going in each one of these. So what we do is we switch on the input parameter scene type or scene, and then we check to see if it is equal to a set of scene types. So these scene types are of course defined in our scene type enumeration. So we check to see if the scene type is game, then we want to return game. So this constant that we're returning here must be exactly the name of the scene that you have in Unity. So we're going to end up creating a scene called game with an uppercase G just to make sure that this criteria works. We currently have a scene type called menu, so we're good there. So in the event that a scene type gets passed in that maybe isn't supported by the system for whatever reason, then it would fall to this default case, and then we would log that warning and then return empty. Okay, so similar to the previous function, we are switching on the scene, and we're checking a couple of string cases this time instead of the scene type cases. So in the case that the scene name is game, then we return the scene type.game. Same thing with menu. In the event we get some string that isn't supported, then we fall to this default condition and we log the warning and return a scene type.none. So that concludes all of the functions that we need inside of our scene controller. We may have some errors, so let's go back to Unity and make sure we clear those up. Okay, so it looks like we only have one error, and it is the integration error. So we have the, if we double click this, it'll take us to this line where we're checking to see if menu.page is on for the loading page. So that is a function that hasn't actually been created in the menu, and that's one that we want to go ahead and integrate. Before we do that, I want to, I want to comment this out because I want to make sure that we don't have any errors in this scene controller before we move on. So what I'll do is I'll just return like that. And again, the reason that I'm doing this is to see if I can catch any other errors inside of the scene controller before we go on and change things in the page controller. Okay, so it looks like everything is actually good. We'll go back to our scripts and make the necessary modifications. So I'm going to uncomment this. Okay, so what we have is a function that hasn't been implemented in our menu management system yet. And what that is using the page controller, asking the page controller if a certain page type is on. So we have our menu scripts over here. Let's go to the page controller and then add that function in. Again, if you're tuning into this part of the tutorial and you've been skipping around a little bit, this is a system that we created in a different tutorial. The link is in the description, and we're just making an integration into that system. Okay, so we want to add a public function to determine whether a certain page is on. So we can add that under this function here. So this function is pretty straightforward. We call it pages on. It takes an input parameter page type. The first thing we do is determine if this page even exists inside of this menu system. And if it doesn't exist, then we want to go ahead and notify the developer and then just simply return. So we'll go ahead and return false here. Finally, what we do is we just get the page on type and return a property on that page dot is on. And whether that evaluates true or false is dependent upon that actual page. Okay, so we're going to have to add this property to the page class. But before we do that, I do want to add one more thing to this page controller to make sure that it doesn't actually get destroyed if it's a singleton. So up here we have our awake function similar to our scene controller. We're checking to see if the instance exists or not, and then we're initializing the instance. So what I want to do down here is just say, just like we did in our scene controller, I want to call it don't destroy on load, because this page controller, since it's going to have a loading page presumably, it's also going to be persistent with the scene controller. And just in case these two scripts are on different objects, which they probably will be, we want to make sure that we're doing this, we're making this call on both of the scripts. So otherwise, we can go ahead and destroy this just like that. Okay, so that's all we need to do on the page controller. But again, to make this integration complete, we need to go to our page class and add this is on property. So from our page class, we're going to add a new property or another variable under here under the animator variable. So we're going to say private bool, and we're going to call this isOn. Then we're going to have a public accessor for this called isOn. This isOn property is what the page controller is using that we just defined in that function. So this is the property that it's going to be grabbing. So what we're going to do here is simply return that variable. And then we'll have a private set, which is just going to set that variable. Just like that. So now we have to figure out where inside of this page controller we want to set the value of this isOn property. So down here in our animate function is where we're going to set the property, but we're also going to do it inside of the coroutine for await animation. So here inside of our condition, if not on, we're going to say isOn is equal to false, but then we'll also have an else condition here to set isOn equal to true. So what we're doing here, just to sort of recap, is we're checking to see if we're using animation on this page. If we're not using animation, then we can just directly set this isOn property to true and false based on whether or not we're turning this object on or off. So this is an instantaneous position that we're taking where we're just instantaneously setting isOn to true or false. But if we're animating, then we need to set isOn to true or false inside of the coroutine. So let's go down to this coroutine and add that down here. So at the end of the coroutine, we're going to do pretty much the same thing. If not on, then we set isOn to false, but we want to do that before we set the game object to deactive. So isOn is equal to false here. Otherwise, isOn is true. Okay, so that's all we need to do for our integration. So our integration should be complete. Let's go back to Unity and see if we have any errors. All right, now that we don't have any errors, we want to go ahead and create two scenes. We already have one called menu. We're going to want to create another one called game. And then in each one of those scenes, we're going to have some UI to tell us which scene that we're on. Okay, so remember we just, whenever we're integrating the page controller, the menu system, we made sure that the page controller is going to be persistent. So we're going to call this persistent UI because we're going to have some other UI on this scene and we don't want to get confused. So the second UI is just going to be telling us what scene that we're on. So we'll call this new canvas UI. Then we'll create a background for us. And the text will simply tell us what scene we're on. Okay, so now that we have two canvases, we do want to make sure that since we're considering loading pages, that the loading page is always above the other UI. So what I want to do is enable this page. Okay, and the page is rendering in front of the UI, which is good, but the canvases should have some sort order on them. And I just want to make sure that the sort order for the persistent UI is 100. While the other UI is 0. So then I know that the loading page is always going to be over rendered on top of whatever UI is on that scene. That way we can just make sure that the loading page is actually working. Okay, then what I want to do is come over to my test. I need to make sure that I have a scene controller. So I'll click my core systems here. I'll add my scene controller. Make sure that I'm debugging that, and then for my testing object, I'll make sure that I have a reference to that scene controller. Then I'm going to go ahead and drag my tests as a reference to my core systems or as a child to my core systems. That way, because my test object isn't persistent, That way the test object will follow the core systems around, and we'll always have a reference to that the scene controller there through the core systems. So we're moving the test object as a child of the core systems. And from here, let's see. From here, what I want to do is duplicate the scene. And that new scene is going to be called game. Let's see. Looks like we duplicated before we saved. So I'll duplicate again. There we go. So the name of this is going to be game. And remember, the names of these scenes must correspond directly with those functions that we created earlier. Scene type to string and string to scene type. So make sure that the constant string values in there are exactly the same as the names of your scenes that you're using with this system. Okay, so in the game scene, the text that we're going to have is obviously going to be different. That's going to be called game. Just like that. Okay, but in this game scene, we're going to delete persistent UI and core systems, just so it's as simple as possible. Let's jump back to our menu screen or our menu scene here. The last thing that we need to do is make sure that we add both of these scenes to our build settings. So I'll add the menu and then I'll add the game here just like that. Okay, so let's see if we hooked everything up correctly. With our test script, if we press G, we go to the game scene. If we press M, we go to the menu scene. And when we press G, it's going to load, it should load the scene instantaneously. If we press M, it should give us a loading screen, and then remove the loading screen after the scene is loaded. So let's just play this. I'll hit G to go to the game scene. Okay, so we're on the game scene. Now I'll hit M to go to the menu scene. Okay, so you can see the loading page comes up, then we load the scene, and then the loading page fades out. So that works very nicely. So since those tests passed and everything looks good, minus this error from a separate system unrelated to this tutorial, we're going to go ahead and close things off. Hope you guys enjoyed the scene controller tutorial. We have one more in the Game Essentials series, and that is going to be session controller. So we're going to talk about how to integrate that in the 5th episode of this series. And then from there, we're going to be creating some mobile games for Android and talking about how to develop those games throughout the year. So thanks everybody for watching. Subscribe if you liked the video, and don't forget to drop a like and share this with a fellow Unity developer who is struggling with scene transitions. Thanks everybody, and I'll see you in the next video.